Every great leap is lit by a new kind of fire. To reach Kardashev level 1, a civilization powered by quadrillion watts, we would need 500 times the energy we use today. That's like powering every building, EV, and server on Earth, not once, but 500 times, or lighting up 166 trillion light bulbs. AI is the next fire, and the infrastructure we build today will define how it spreads. The steam engine gave us industry. The grid gave us cities. The internet gave us speed. And now, AI is demanding something even bigger: planetary scale power. Let's talk about how we build it. I'm Greg Osuri, an open source developer turned founder. My roots are in distributed systems, Kubernetes, Terraform, the tools that build the cloud. But the cloud we built wasn't open. It became a walled garden, powerful but centralized. That's why I built Akash, a decentralized peer-to-peer supercloud that unlocks underutilized servers worldwide. It's faster, it's cheaper, it's permissionless, and it's already running thousands of workloads from the web apps to AI inference apps. But what gets me most excited is what we're doing next: creating a global AI cloud that no single company controls and that anyone can help power. In 2023, US data centers consumed 176 terawatt hours. That's about 4.4% of the entire national electricity output. And the Department of Energy now warns that by 2028, that could be more than triple to as much as 12% of the grid. Why? Because AI isn't just a user of compute, it's a devourer of energy. Training frontier models can consume tens of millions of kilowatt hours, but inference, the work of actually running those models, adds an ongoing and expanding baseline. We're already seeing this play out. Utilities in Virginia and Texas are hitting capacity. In some regions, data center projects are being paused or rejected because there simply isn't enough energy. This isn't a future problem. This is a now problem, and we can't solve it with more chips alone. We need to rethink the entire compute energy stack. Let's visualize the issue. Imagine two curves on a graph: a compute demand growing exponentially, a grid capacity growing linearly. By 2026, Gartner says 40% of AI data centers may be unable to secure sufficient power. In Northern Virginia, utilities are overwhelmed. In California, interconnect queues stretch 3 to 5 years. This is a bottleneck, not bandwidth, not GPUs, it's electricity. And when power becomes scarce, compute becomes fragile. We need new thinking, not just faster chips, but faster interconnects, faster permitting, and most importantly, smarter architecture. To break the bottleneck, we need to pull three levers together. Number one, radical efficiency. Smarter models, sparse architectures, token-level routing. Let's stop wasting watts. Software has room to grow significantly. Optimization and scheduling alone can cut inference costs by 30 to 50%. Number two, massive clean supply. We need to build renewables, geothermal, advanced nuclear. The cleanest power is the power we can actually connect. But the biggest challenge here isn't generation, it's grid integration. We need policy to catch up with the physics. Number three, decentralized compute. This is a game changer. Instead of building 10 massive data centers, what if we could tap into 10,000 smaller ones? Colos, edge nodes, university clusters, even your basement rig. And that's what Akash does, ties them all together, monetizes their capacity and routes workloads wherever they can run efficiently. This model isn't just about spreading compute, it's about aligning compute with energy. With decentralized compute, we can co-locate jobs near renewable generation, like running inference on a solar peaks or training models where near idle wind capacity. Oops. I apologize. How do I go back to the slide? It also opens doors to new participants, schools, co-ops, small operators. We're not waiting for a new hyperscale zone to get approved. We're using what we already have. It's not just about scalable, it's about equitable, flexible, and resilient. Until recently, decentralized AI was just considered impossible. Too slow, too fragmented, but in 2025, that changed. Pluralis introduced async swarm training. Nodes train shards independently, even with low bandwidth, using Nestera momentum to keep learning stable. Jensen trained a 72 billion parameter model on a decentralized testnet. No campus, no cloud, just thousands of volunteers with GPUs. Bagel used ZK LoRa, a zero-knowledge proof system to verify decentralized fine-tuning without needing to rerun it. Noose is training a 405B parameter open model using distributed GPUs and async optimizers. These breakthroughs didn't just prove a concept, they revealed a new frontier. We're seeing models trained across continents with compute contributed from living rooms, research labs, and micro data centers. Verification is cryptographic, scheduling is permissionless, and trust is built into the fabric. This is the architecture of the future. A planetary AI mesh alive with local energy and local compute, redundant by design because there's no single points of failure, open to anyone, anywhere to learn, to build, and to contribute. Together, these systems make intelligence more resilient, more inclusive, and more aligned with democratic values. The future isn't hyperscale, it's hyper-distributed. The vision is bold, but it's not abstract. It's operational. It's called the Akash Star Cluster. This is how we scale decentralized compute from prototype to planetary. Phase one is data center scale star nodes. We begin with data center grade deployments, high power racks in colos, regional data centers, and trusted facilities. These are our backbone built for capacity, uptime, and training class workloads. Each star node is owned and operated by a node keeper and an independent provider who installs the hardware and earns revenue by serving real AI jobs on the network. Phase two, Telco edge nodes. Next, we move into a telco layer. Fiber exchanges, cell sites, regional hubs. These locations are already wired for performance and coverage. They bring compute closer to the edge. Ideal for inference, real-time AI, and user-driven latency. This phase lets us tap into infrastructure that already exists and is massively underutilized. Phase 3, homes, schools, and communities. Finally, the long tail. Personal rigs, campus clusters, solar-powered school servers, every extra GPU becomes a part of a global AI mesh. Every participant earns by distributing or contributing compute. This isn't charity. This is the new compute economy. Each phase expands not just capacity, but access, not just scale, but sovereignty. We're not building megastructure in one place. We're building a planetary supercloud, node by node, rack by rack, powered by the people. Let's talk numbers. One NVIDIA GB200 LVL72 rack draws about 120 kilowatts. It holds 72 of the most advanced GPUs ever made. To reach a gigawatt compute, about 8,300 of these racks, traditionally what would mean a dozen hyperscale campuses, but with Akash, those racks can be anywhere. A gigawatt of AI compute doesn't need to live in one building. It can be distributed across colos, homes, schools, and telco sites. That's the magic of disaggregation. We're not bottlenecked by real estate or substation permits. We route around the constraints. And when you spread the infrastructure, you unlock cheap energy, localized cooling, idle hardware reactivation. This is how we build a planetary scale cloud without building a planetary size warehouse. Gigawatt power without the gigawatt footprint. So, how do we fund this all? Not with mega project loans, not with billion-dollar data center REITs. We do it with a new model of infrastructure capital, fractionalized, transparent, on-chain. We call them star bonds. Each star bond is an NFT that represents ownership in a specific node. When you mint one, you're backing the deployment of a real-world rack by a node keeper in a real facility serving real AI workloads. In return, you earn a pro rata share of the node's revenue automatically on-chain without intermediaries. It's like staking, but instead of securing a blockchain, you're powering intelligence. This model aligns between capital, you, the backer, infrastructure, the node keeper, and utilization, the AI workloads themselves. It unlocks a new asset class, performance-yielding AI infrastructure. No speculation, no hype, just hardware, revenue, and compute. And most importantly, it opens door for anyone. And here's where things get really exciting. When you decentralize compute, it becomes mobile. It can move with energy. Imagine AI training jobs chasing solar peaks across Arizona rooftops. Inference pipelines migrating dynamically with Kansas wind. GPUs spinning up where renewables are cheap and idling when they're not. Instead of compute demanding power, power attracts compute. This flips the entire model. We no longer are forcing workloads into mega clusters and then scrambling to power them. We're letting jobs flow to where the energy is cleanest, cheapest, and the most abundant. We turn the grid from a constraint into a canvas. And because Akash Network is programmable, this isn't theory. Workloads can respond in real time to price, carbon intensity, and load automatically. This is how you get energy-aware AI. And this is how compute and clean energy grow in lockstep. It's not just decentralized infrastructure, it is synergized infrastructure. And here is a national security case for decentralization too. When compute lives in a dozen hyperscale zones, it's easy to surveil, easy to disrupt, easy to control. But when compute lives in 12,000 locations, it's resilient, it's redundant, and it's harder to censor, harder to kill, and harder to co-opt. Decentralized AI infrastructure gives us strategic depth. It gives us failover, fallback, and federation. It's not just a technical advantage, it is a geopolitical one. In an era of cyber warfare, surveillance states, and infrastructure sabotage, centralization is a liability. But decentralization, it is the defense by distribution, security by architecture. And when that infrastructure is rooted in US soil, powered by US innovation, and governed by US open standards, we lead not just a performance, but by principle. We don't win the AI age by concentrating compute. We win by distributing it. And that's the American advantage. Freedom, openness, and resilience. Let's build an AI infrastructure that reflects those values. To make this vision real, we need a clear path. Here are 5 things policymakers can do right now. Fast-track permits for small-scale distributed data centers, just like rooftop solar. Reform interconnect queues so clean power and edge nodes can plug in faster. Offer tax incentives for decentralized compute infrastructure, treat it like any other critical green tech. Accelerate licensing of SMR, modular nuclear reactors that power AI workloads cleanly. Number 5, clarify deepen legality so token infrastructure like Akash doesn't get entangled in security laws. These aren't speculative ideas. These are actionable unlocks. The same way tax credits supercharge solar, this agenda can supercharge open AI infrastructure. The good news, you don't have to wait for permission to build this future. If you're a builder, deploy your models on Akash. We support all major frameworks. It's live, permissionless, and performant. If you're an operator, spin up a star node. Whether you are in a colo or a garage, you can contribute compute to the network. If you're an investor, scan the QR, reserve a star bond, and earn a share of the global AI workloads. This isn't about infrastructure, it's about participation. We're not watching this future happen. We are creating it node by node. You don't have to be a tech giant. You don't need a $1 billion campus. All you need is curiosity and the will to help build something bigger than yourself. From solo hackers to university clusters to community micronodes, this movement is open to all. The next great leap in AI won't be handed down. It will be built by the builders and backers like you. So let's get to work. Let's end where we began, with the idea of a planetary leap. A Type 1 civilization doesn't emerge from one cloud provider. It emerges from a network of millions, coordinated, open, and alive. We now have the tools, the compute, the capital, and the will. Let's build a cloud that reflects our values, a cloud that can't be shut down, a cloud we own together. Let's meet at Kardashev 1. Let's build together. Thank you.